Hello everyone, I am Shivanandan Reddy Katterapalli, currently pursuing Masters in Agriculture Sciences at University of Southern Queensland, and today I will be presenting my research question on what are the environmental factors influenced by the production of bioethanol from sugar molasses in Australia. This presentation is a part of my course which is essential for professional scientists. To start with the introduction, what is bioethanol? Bioethanol, also known as ethyl alcohol, is used as a renewable fuel which is produced from cellulose-rich plant-based sources. Commercially, it is produced through fermentation of carbohydrate sugars and then blended with petroleum products. Generally, the blends are in the form of E5, E10 and so on till E100 for petrol and B5, B10 and so on till B100 for diesel. Here, the numerical digit represents the percentage of ethanol and balance is conventional fuel. Depending on the sources of feedstock, the bioethanol is classified as first generation, second generation, and third generation. If you look at the diagram, the bioethanol generates a circular economy where carbon dioxide generated from automobiles is used by plants which are used as source for ethanol production. If we come to the third slide, why do we need bioethanol? In recent years, the global shift towards renewable energy has led to increased interest in biofuels as an alternative to conventional fossil fuels, which puts tremendous pressure on energy resources. Biofuels, primarily derived from agricultural crops, present a promising solution for reducing greenhouse gas emissions and lesser dependence on fossil fuel resources. As the world grapples with the dual challenge of escalating energy demands and environmental concerns, the spotlight has turned to bioethanol, a renewable energy source derived from biomass. In the present scenarios, majority of the energy demand is met by fossil fuel burning, accounting for greenhouse gas emissions, accelerating the global warming and climate change. In this context, the vehicular pollution constitutes about 75% of the global greenhouse gas emissions. This scenario identifies the reason for clean energy fuel as an alternative to the petroleum fuels. Day by day, the energy demand has been arising among many other non-renewable sources of energy. Bioethanol from agriculture feedstocks has been promising to replace the existing fossil fuel dependency. It is often considered as green energy as there is no emissions and in some cases reduced emissions of greenhouse gases. Looking at the picture, we can clearly understand how applications of ethanol is being diversified. Coming to the next slide, Australia bioethanol landscape. The Australian sugarcane industry is geographically highly dispersed and predominantly situated along a 2000 km stretch of the Australian east coast, North Queensland and New South Wales. Owing to the production capacity of sugarcane, Australia has enormous supply of sugarcane to maintain the consistent supply of sugarcane for bioethanol production. In terms of capacity, Australian biorefineries have the potential to produce 440 million liters per year. The Australian government has planned a diversified ecosystem to support ethanol production. The challenge lies in balancing the food security and ethanol production along with the greenhouse gas emissions involved in the ethanol production. The question is, can the 2050 target be achieved considering the present growth of ethanol production? Coming to the next slide, what is the importance of this research question? This research question is important for several reasons. Due to its no or minimum greenhouse gas emissions, bioethanol is often labeled as a green alternative to fossil fuels. However, the question is the ethanol production really a green solution? Which can be evaluated by life cycle analysis of ethanol production, followed by environmental impact assessment of ethanol production, where the environmental costs like land use patterns, land degradation emissions from processing, and impacts on water or soil can offset the benefits if not properly managed. The central concern in ethanol production revolves around the intricate interplay between food security and energy security. As the Australia is targets net zero emissions by 2050, the research question is significant in evaluating the environmental impacts of the ethanol production by exploring the environmental impact assessment and life cycle analysis in the Australian context. We can also assess whether producing ethanol from sugar molasses aligns with long-term sustainability goals or instantaneous clean solution to the fossil fuels burning in industrial and automobile. The insights from this research can guide policymakers in framing better sustainable ethanol production practices and achieve the target 2050 by biofuel industry in improving practices and help the public distinguish between truly green solutions and those that may cause unintended harm. It contributes to both scientific understanding and practice decision making. Here we can see the life cycle analysis of ethanol production. Life cycle analysis of ethanol production evaluates the environmental impact of ethanol production, encompassing all stages from raw material extraction to final product use and disposal. This analysis helps understand the overall sustainability of ethanol production and identifies areas for improvement. It further identifies the boundaries of the system and impact metrics. In this picture, we can see that represents a full life cycle assessment of bioethanol production from sugarcane. It evaluates the process flow from starting at the farm to the application in vehicle. As you can see here, greenhouse gas emissions occur at each stage, starting from farming through biomass transportation, refining, and distribution. Fossil fuels are also involved throughout the process, especially for transportation and production. Interestingly, while ethanol reduces fossil fuel use in vehicles, still its production is partially dependent on fossil fuel burning in one or the other stages. Through life cycle assessment, we can understand the net environmental impact of bioethanol and identify where sustainability improvements are needed. Coming to the life cycle assessment, greenhouse gases emitted are lesser than that of the greenhouse gas emissions controlled through fuel blending. This observation provides an area of research in reducing the greenhouse gas emissions during the production of ethanol, thus giving rise to sustainable production of ethanol. Coming to the next slide, here we can see the environmental impact assessment. Environmental impact assessment is a process used to evaluate the potential environmental. In the context of ethanol production from sugarcane, environmental impact assessment focuses on specific environmental dimensions such as air quality assessments, examine emissions during refining and ethanol transport. Water assessments consider both the high water demands of ethanol production and the risk of contaminating nearby waterways through wastewater discharge. Soil degradation and biodiversity loss from sugarcane cultivation are also considered. It helps identify, predict, and assess both positive and negative impacts on the environment, which is adapted to make informed decisions to consider environmental consequences and to identify ways to avoid, reduce, or offset any negative impacts on the environment. Environmental impact assessment is crucial in Australia because it aligns industrial activities with environmental legislation as the sugarcane production is spread across the sensitive zones, comprising estuaries, mangrove forests, wetlands. Further, environmental impact assessment ensures that ethanol production from sugar molasses in Australia is ecologically sound, legally compliant, and socially responsible, while supporting the transition to renewable energy. Interpreting the life cycle analysis and environmental impact assessment, both the approaches provide a wider insights in the ethanol production, while life cycle assessment approach is used to evaluate the net environmental impact of bioethanol and identify where sustainability improvements are needed. Environmental impact assessment provides a ground level lens to identify and address risks associated with ethanol production. Together, life cycle analysis and environmental impact assessment can be used to study the impact of ethanol production on environment. Concluding the presentation, I would say that the producing bioethanol from sugar molasses in Australia presents a promising path towards clean and renewable energy, but it is not without its environmental challenges. Throughout this presentation, we have examined how the production cycle of influences greenhouse gas emissions and eventually impacts soil, water, and land use. Further, tools like life cycle assessment and environmental impact assessment allowed me to see both the broader perspective of environmental footprint and their site-specific risks. These frameworks help to frame responsible policies and industry practices to safeguard the interests of environmental. I would call such motive as the sustainable production of ethanol, where greenhouse gas emissions produced during the production are limited, or minimized to have larger scale of benefit. As Australia continues its transition towards clean energy, research like this plays a crucial role in ensuring the sustainable production of bioethanol from sugarcane. And these are the references. Thank you so much for your time and attention to my presentation. If you have any questions, please ask me in the discussion forum.